In this lecture, we're going to go through SPSS in conducting a multiple regression analysis. And so here we see our fictional study where we have data from all 50 states of the United States with respect to life expectancy, high school graduation rate, income level, and this is on a per capita or per person basis per month, and the murder rate for those individual states, with the intention here, the objective of examining the relationship between these three variables as predictor for our outcome variable, which is life expectancy. So before conducting a multiple regression analysis, it's often recommended that a correlation matrix first be generated. And so I'm going to do that right now. So I'm going to go to the Analyze option in the menu, and I'm going to correlate, and I want bivariate correlations. I can do bivariate with confidence intervals, which is typically done, but I'm just going to do the bivariate for now. So I have my four variables, and I'm just going to shift and click all and move those over. And just to double check here under options, I can produce the descriptive data, but I'm going to decline that at this point. And I'm just going to generate the correlation matrix for these four variables. I just hit OK. And what we see here is we have the correlation matrix for all four variables. So for each R value, there's an associated level of statistical significance. So this is our p-value, and we have our sample size for each correlation. So for each correlation, we have all 50 states entered. And SPSS will flag the statistically significant correlations. We're now going to move on to conducting the multiple regression analysis, but I'm going to enter in the predictor variables one at a time. So with SPSS, I don't have to go back to the spreadsheet. I can start right here and append the subsequent analyses in the output file that we have right here. So I'm just going to go back to Analyze, and I'm going to click Regression, and I want linear. Now I had this done a little bit earlier, so I'm going to pull these back over here, and I'm going to pull this back over here. So what we have here are our variables typically that you will see on the left hand side, and the very first item that I have to identify is my outcome variable, or my dependent variable, and that'll be life expectancy. So I want life expectancy, that's the main one I'm interested in, and I'm going to click just high school graduation, and I'm going to pull that over to the predictor variable right now, and I'm only going to examine this one right here. So if I go to statistics, as you can see here, the model fit, which is what I want, the R squared change, which we won't interpret at this point, but it's something that we certainly want to click. We want estimates for the regression coefficients as well as the confidence intervals, and so I'm going to continue with that, and I'm just going to go ahead and hit OK. And what we see here, and I'll just scroll up, once again we have our correlation matrix, and the subsequent analyses are just appended to this output file that we can save. And so what we have is our ANOVA table, which is what we need. We have the output for the regression analysis, which will include the R value, the R squared, and something called the adjusted R squared. But what we need to include in our output is our ANOVA table, and as you can see here, the results indicate that this was a statistically significant prediction of life expectancy from high school graduation rate. And we have our unstandardized coefficients for our y-intercept and our slope for the relationship between high school graduation rate and life expectancy. So now I'm going to rerun this analysis. I'm just going to go back up to the top. I'm going to analyze, back to regression, linear. Now I'm going to add income level. And I'm going to do this again. And as we scroll up here, so once again here we see our first analysis, our second analysis, and our third analysis, which includes the two variables that are entered. And we see that the R squared value is just slightly greater when we include two predictors into our model. The results are statistically significant, as we can see here from our ANOVA table, and we have the unstandardized coefficients once again here with our y-intercept and the slope for each of the two separate predictor variables for high school graduation rate and income level, but the slope for income level was not found to be statistically significant, hence the very small t-value and the very large p-value for the income variable. Now I'm going to finish this up with one more analysis. I'm going to click linear and I'm going to click murder rate. Now I'm going to generate a regression model with all three predictors at the same time. So we see here we have murder rate, income level, and high school graduation. Now by including the murder rate, here we have a big jump in the R squared value comparably to the previous analysis where we had two predictors at 0.34 for our R squared. Now when we entered in the third variable, we see a big jump in the R squared value at 0.664, and the ANOVA table confirms that all three predictors were found to be statistically significant in predicting the outcome variable, which is life expectancy. And our regression table here presents our y-intercept and the slopes for each of the three separate predictor variables entered into the model, and you can see here that the murder rate slope was found to be significantly different than 0, with the large t-value and the very small p-value associated with that slope. So this ends our video on using SPSS to conduct a multiple regression analysis.